Okay, so moving on to 6.1 measures of central tendencies. So some of the stuff you've done before in the past, probably grade 8. So doing mean, median, and mode. Okay, so we're taking that, what you learned, and we are taking it further. Okay, so we have so we're going to start with mean, which is the average. So mean, you just add up all your values, and then you divide by how many there are. Okay, so sum of all the entries divided by the total number of entries. But we have 4 different formulas for the mean. Okay, so what you've done in the past is just x1 plus x2 plus x3 plus x4, which is just adding all the values together, and then divide by how many there are. Okay, so here x1 plus x2 all the way to xn. This n here represents the total population. Okay, population or the number of entries. Okay, and this symbol here, it looks like this. So it kind of looks like an M. It kind of looks like an M, and it kind of looks like a U. So it's actually called a mu. So it's a U, and let's extend the front piece. Okay, so it's a mu. Okay, so that's for population mean. Sample mean is the exact same formula, just different letters. Okay. So we have different letters. We have a small n here, which would be the sample size. And then we have our x here. So you have to make a correction to the note. So it's x, and it's supposed to have this line on top. Okay, this line on top looks like a bar. So this is called x bar. So x bar. Okay. Make the correction here as well. So x on top. So it's x bar for this one. Okay, so population and sample means exact same formulas, just different letters. Okay, then we have mean for group data. So I'll do an example with all of these. So so this is the frequency times the midpoint. Okay, frequency times the midpoint, and this is sigma. So we're adding up all the frequencies times its midpoint, divided by the total number of frequency, the total frequency. Okay, then we have something for weighted mean, which we've done already. So that's the, except for we're doing weighting here. So we did each x value times it by its weight. Okay, so we did this in the previous chapter. Okay, and then sigma. So W is weight, the weightings, F is frequency, M is midpoint. Okay, so then we get to, that's the mean, then we have median. So median is the middle value. Okay, so when you list out all your values, least the smallest to largest, or the least to the greatest, we take the middle value. Okay, you must make sure that the entries are in order. If they're not in order, you cannot do the median. Okay, if there's 2 middle values, so it's not just one, there's 2, add them together and divide by 2. So take the average, add them together, divide by 2. Okay, then we have mode. Mode is the most frequent number. Okay, so I want to go back to median for a second. So median is the middle value. If you notice on the report cards or midterm report cards, it says the class median. Okay, they use the median because it's the middle student, the middle person. Okay, so it's an equal number of entries above that value and a same number of entries below that value. They used to do mean or average, but they don't do average anymore on the report cards. And that's because one really low mark brings the whole class average down, whereas a really low mark would not affect the median at all. Okay, so average is sometimes not very accurate. It can be accurate, but not all the time. So we use median we use that now for marks. Okay, then, mode is the most frequent. Okay, so for instance, we have this 1, 2, 2, 3, 4, 5. These were my values. Mode is the most frequent, so this would be 2. It comes up twice. But if, say, we had multiple numbers with 2, so we have 2 2s and 2 5s, then our mode would be 2 and 5. Okay, so it's possible to have more than one mode. If it's just one number of everything, there's no mode. Okay, outlier. Okay, this is something you learn in grade 9, grade 10, grade 11, and after in actually chapter 7, which I don't think we'll get to, is actually a formula to calculate to see if something is an outlier. Okay, so this is something that's different from the rest. So for instance, if I had a graph that looks something like this, and then I had a value that was kind of off the side, this would be considered an outlier, okay, because it doesn't follow, it's not within the trend of the graph. This could happen in a histogram or bar graph as well. So you have a whole bunch of bars marked together, and then you have one that's off. So this would be an outlier. Okay, now we're going to get to distributions. So distributions, not in the fact that the ones we just did. We're looking at distribution and with regards to the graph. Okay, so different type of distributions with regards to graphs. Sorry, just 1 second. Okay, so we have three different types of distributions with regards to the appearance. So we have ones like this one. Okay, so the first one here is called normal distribution. This one is called negatively skewed. Or left skewed. And this one's positively skewed. Or right skewed. Okay, so normal distribution, negatively skewed or left skewed distribution. Okay, we call it left skewed. We have the tail, so the tail's on the left side. And anytime we go to the left, we're going negative. Okay, negatively skewed or left skewed. With this one as a tail going to the right, so we have a positive skewed or a right skewed. Okay, so what does these tell us? So when you have a normal distribution, so these are a bunch of values, okay, entries. So in the middle here is our mode, our mean, median, and mode. Okay, so as a school average, this here would be, say, the most entries would be at the 68%, whereas you have 70s and 80s, and then you have a bunch of 90s, and you also have 60s, 50s, and low values here. Okay, in a normal distribution graph, the mean, median, mode are all the same. Okay, they're all one value, which doesn't happen all the time. So then we have negatively skewed. Okay, so this is where you have a bunch of entries here. Okay, this is, I believe, R marks in our class. So we have some people are doing lower, some people like 60s, 70s, or 60s, and then we have a bunch of students here, 70s, 80s, and a couple of the 90s. Okay, so here what happens is we have our most students here, which is our mode, the most frequent results, say that's about an 80 average. Okay, but we have these students over here that are struggling. Okay, so what happens is these entries here, instead of the mean, median, mode here, well, the mode's here, now the middle student is over here, which is at the median. Okay, and then what's get affected the most, because we have multiple students here in this lower area, is the mean drops. The average of the class drops. So we have a lot of people here is the most frequent, say this was an 85. Then we have our median, say this is at 80 or 75, but then the average comes down to about 72 because of some students that are not doing so well. Okay, likewise with right skewed, you could have a bunch of students here. So this would be the mode. The highest point is always the mode. Okay, that means the most entries. Then we have a bunch here, but then we have there's so many entries this way in a positive direction. So what happens is our median is going towards the tail, and then our average gets brought up from these entries that are high. Okay, so the median is always in between. The median is always in between the median mode for the left and right skewed. Normal, they're all the same spot. The mode is always at the highest point, and then our average is always the last, either more to the left or more to the right. Okay, next. Okay, number one, let me just increase this. Okay, before heading on vacation to Mexico, you observe the actual high temperatures for 7 days. The table shows the results. Okay, determine the mean, median, and mode. Okay, so since you're just watching for 7 days, this is not every single day, it's just 7 days. So we have a sample size. Okay, so we have a sample. So we have our mean, we're doing our mean first. So X bar represents the symbol for mean, for sample. So we're gonna add up all these values and divide by how many they are. So 27 plus 29 plus 32 plus 29 plus 45 plus 29 plus 31, and divided by the 7 entries that we have. And when you plug this in, you get 222 divided by 7 gives you an average temperature of 31.7 degrees Celsius. Okay, now for our median. So the median, you have to list from the smallest value to the largest value. Okay, so we have 27 is our lowest, then 29, 29, 29. And 31, 32, and 45. Okay, so I cross them off as I go just to know so I don't repeat numbers or I don't miss any. Okay, so I listed them out here. So now with the median, I'm just going to cancel out from the sides. So take one off each, then move again, and then move until you have 1 or 2 values left. So here we have the middle one of 29. So this is our median. Okay, so again, cover 1 point or 1 point on each ends, and then go 1 by 1 to hit the middle. So you have the median of 29. And lastly is our mode. Our mode is the most frequent number. So in this case, 29 is our mode. because it appears 3 times. Okay, so B, is there an outlier? How does it affect the measures of central tendency? So central tendencies are these 3 things. So if there's an outlier, how does it affect these things? So we definitely have an outlier here. This 45. Okay, so 45 is definitely, doesn't follow the trend. All the rest are from 27 to 31. Okay, so what the outlier does, it does not, in this case, it does not affect the median or the mode. Okay. This does not affect the median or the mode, but increases the mean, which is the average, quite a bit. Because if you look at it, it says the average is 31.7 degrees, but if you were to look at the results, there's only 2 days out of the 7 that were actually higher than 31.7. Only 2 of them, one was 32, one was 45. So this doesn't really represent the temperature of the week, because all the other ones, there's 5 days that were under this temperature, and there was actually 4 of them that were under the temperature of 30. So what happened is that 45 brings up the average quite a bit. So this is not a true estimation on the temperature, whereas these 2 actually do a good job at being at 29 degrees. Okay, which measure would best represent the temperatures? The answer for this is almost always median. Okay, or I would say pretty much every time it would be the median, because the median is the middle value. Okay, so that would be the best representation, so the median. In this case, it's actually both. It's median and the mode, since it's the same number. But in most cases, it will be just the median, because it's the middle value and it's not affected by outliers. So median, not affected by outliers. And the mode is the same as the median in this case, but that doesn't usually occur. Okay. Let's get to the next example. A group of children were asked how many hours a day they spend playing video games. The table shows the values, which would be S. Determine the estimated mean, the median number of hours, and the modal interval. Okay, estimated mean number of hours, and modal interval. Okay, so we have estimated mean, but there's 4 formulas for mean. So we have to go in to see which one does this fall into. Okay, so if we go up to the charts, we have these 3 here. Well, we don't have the individual measurements, okay? So we don't actually know the number of hours, we just gave us a range. So from 0 to 2, 2 to 4, 4 to 6, and so on. So we have 3 entries in here. So that could be an hour, it could be half an hour, it could be an hour and a half, we don't know. Okay, so it's none of these 2. Then we get to say weighted mean has to have a percentage. Well, we don't have any percentages here. So that leaves us with the one here is the mean for group data, the average for the group. Okay, so the group in this case are the kids, the children they asked. Okay, and what we also have here is a frequency and a midpoint. Okay, so this is the frequency. So the number of children that fall into this category is 3. So the frequency is 3. Then 11, 7, 2, and 1. So we have a frequency here. So x bar the frequency times by the midpoint all over the total frequency. Okay, so what we're doing here is you're taking each frequency and multiply it by the midpoint. So in this case, we have 3 children, and we're going to multiply it by the midpoint. So the midpoint is of here. So what's between 0 and 2? What's the middle value? The middle value is 1. Then we have 11 is the frequency for the next one, times the midpoint. So the midpoint of 2 and 3, so the middle value is 3. Okay, then we continue. 7 times 5, 2 times 7, and 1 times 9. Divided by the total frequency. So total frequency is 14, 21, and is 24. So divided by 24. Okay, I'll do this in multiple steps. So 3 plus 33 plus 35 plus 14 plus 9 divided by 24 plus 9, 13, 18, 21, 24, 2, 94 divided by 24. I have it here is 3.9 hours. Okay, so 3.9 hours this is just the mean. Okay, so now the median is we have to put them in order. Okay, this one's a little bit tricky. So we have to find where the middle value is. Okay, so if we have 24 entries, then the middle entry would be at 12. So half of this is 12. So there's 24 entries, the middle one would be at 12. Okay, so we have to know where the 12th entry is. So the 12th entry. Okay, so if you can imagine that we have 3 at here. So imagine they were all an hour. So you have an hour, an hour, an hour. Okay, or she'll do it up here. So you have 1 hour, 1 hour, 1 hour. Okay, then you have 11 students, children, doing the numbers from 2 to 4. So let's imagine they were all 3 hours. So then you have 3 at 3 hours for 11 students. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, then you have 7 students of 5. 1, 2, 3, 4, 5. And then 2 students at 7, and then 1 at 9. Okay, I don't want you to do this because there might be ones here that have 100 entries, and I don't want you to list out all the possible ones, okay? But I'm just using this as a visualization. So if you were to count from the sides, you'd go like so until you got to the middle value, which is 3. Okay, so our middle value of 3 would be our median. Okay, the better or easier way you could do this is by looking at the chart. Okay, so you know the first 3 are here. Okay, then you know there's 11 entries in this area. So 3 plus 11 would bring you to their 14th entry. So the entries from 3 to 14 would fall in this area. We want the 12th entry. Well, the 12th entry is in between here, so this is our median. So the median is from 2 to 4 hours. From 2 to 4 hours, but you want the middle of that. So the middle from 2 to 4 is 3. Okay, so we want the middle of 2 and 4, which is 3 hours. So our median would be 3 hours. And our mode, okay, you'll see modal interval. So they want to know which interval happens the most. Well, that's this one as well, right? So the 2 to 4, so 2 to 4 hours. Okay, the interval, meaning the range, and 2 to 5 happens 11 times. Okay, 11 students here, so that's our modal interval. Okay. B, this is discuss any skewing of the data with respect to the measures of central tendency. Well, there's no skewing here, but you notice our average again is quite high. It's at 3.9. It's almost at 4 hours. So our average is almost towards here, and that's because of these couple people here, couple children who play so often, they bring the average up to 3.9. Okay, but to talk about the skewing, so let's think about the chart. So if I were to graph these, I would have something, I don't know, I'm just going to do this quickly, so 5, 10. So I would have say a graph here, here, and 7 would be here, then I would have 2, then I would have 1. So if you were to make this into one of those distribution charts, it would look like this. So it goes straight up, and then it kind of tails off to this way. So this would be a positively skewed. Or right skewed. So right. So it's positively skewed because their tail is longer here. There's only a couple entries here, but this tails off here. So what happened is your mode is here, which is right. Our mode is 11. Our median happens to be there as well, but our mean gets pushed to the side, so our mean is over this direction. So it's almost at 4. Okay, so because these entries that are higher. Okay, I think this is the last one now. Now going towards marks. Okay, in math, knowledge application are worth 30%, and communication and thinking are worth 20%. If Josh gets 87, 90, 76, and 78 on the respective categories, what would this weighted and unweighted mean be? Okay, so when it says respective categories, that means he got, since 87 is listed first, that would apply to the knowledge. Okay, then application is next, so that applies to the 90. The communication would then be the 76, and the 78 would be the thinking. So the order that these appear are the order of the marks. Okay, so we're going to do the weighted mean and then unweighted mean. So the weighted mean is, it's your x value times by your weight. Was it x that we used? Yes. Divided by the total weightings. So we're going to take each x value, multiply it by a weighting, and then divide by the total weightings. Okay, so we have so we have 87, oops, where did we say that? So we have 87%. Times 0.3. Then we're going to have 90 times 0.3. So 87 is the knowledge, which is 30%. The 90 is the application, which is also worth 30%. Then we have the communication, mark of 76. That's worth 20%. And lastly, plus the 78 times 0.2, which represents the thinking. Divided by the total weighting, which is, you add these all up, it'll add up to 1. So 0.3, 0.3, 0.2, 0.2. If you want to put 30, 30, 20, and 20, you could have, like the actual numbers 30, 30, 20, 20, but then you would divide by 100 at the end, okay, because they would have to 100. So, I have this written down. So you get 26.1 plus 27 plus 15.2 plus 15.6. Okay, and if you add those together, you get an average of 83.9%. Okay, this is your weighted mean. This is because each category is worth a little bit different. Some are worth more than the others. Say we didn't have that. So in this case, this person's mark is 83 average. Okay, say we didn't have it. Say we made every category exactly the same. So if we did it exactly the same, this would be unweighted. So all you would have to do is just add up each entry, 87, 90, 76, and 78, and divide by how many there are, which is 4. If you do this, the mark now goes to 82.75%. Okay, so the mark in this case drops to 82.75. So if we look, that's about a 1.2% difference based on weighted and unweighted mean. This usually works in your favor as students because the knowledge and application questions are usually the easier sections of the test, so they're actually weighted a bit more. Whereas the communication and thinking, or sometimes, well, thinking are definitely the harder questions. Communications can be iffy, depending if you're good at explaining things. So those are worth a little bit less. So usually the marks in the class, these ones are a little bit higher, so that's why they're worth more, which brings your marks up. And these ones are a little bit less, so they don't affect you as much. There's no day 1, day 2 here. Well, actually, is there? Where's my planner? No, so you guys are responsible for this, which is, so this is 6.1. So 6.1 today, 6.2 on Wednesday. For cohort A, you have the Thursday to get caught up with anything because the cohort B is writing the test, and then we'll do 6.3 on Friday. Okay? I hope everybody is well. Hopefully you guys can see this video later today, maybe get started tonight. Okay, so here it's all these questions. So it's going to be 1 to 8. So 1 to 5, 6, 7, 8. So 1 to 8, 10, 13, and 15.